Hello, I'm James Bruce with MakeUseOf.com, and today I'd like to give you an introduction to the Raspberry Pi, everything a beginner would possibly want to know. There are technically two models of Raspberry Pi, Model A and Model B. A costs $25 and was the original with only 256 megabytes of RAM and lacking a network port. Model B, on the other hand, has 512 meg of RAM and costs $35. It's the most commonly available, so most projects and tutorials assume you have a Model B. I would go for that. The first thing you should know about the Raspberry Pi is that it's essentially a mini computer with an ARM processor, memory, and graphical capabilities, and as such it needs an operating system to run. Although a capable computer in its own right, the Pi won't run Windows. Instead, you'll find various flavors of Linux, and there's even a version of RISC OS and Amiga OS that have just been made to work on the Pi. Apologies if you weren't born in the 80s and have no idea what they are. The official operating system is a version of Debian Linux called Raspbian, and in nearly all of my own Raspberry Pi tutorials, which you'll find on MakeUseOf.com, it assumes you're running the latest version and a clean install of Raspbian. For trying things out, it's suggested you download the Noobs image, which is a graphical boot menu to open a couple of different OSs and try them out. Storage is one of the few things the Raspberry Pi doesn't include on board. Instead, you need to supply an SD card with an operating system image loaded onto it, and you should only use Class 10 cards or better. Use a tool such as Win32 Disk Imager to burn the downloaded OS, or copy the Noobs files to a freshly FAT formatted card. Then when you're done, you can insert it into the Pi and boot. The Raspberry Pi is powered by micro USB, the same connector as many Android phones. It's recommended that you use a wall socket to provide a suitably high current, but depending on your model of computer, a standard USB port may suffice, or a powered USB hub may work. For connectivity, every Pi is equipped with a built-in Ethernet interface up to 100 megabit speed. You can also plug in a compatible Wi-Fi interface like this, but whether or not your particular operating system supports it out of the box is another matter. Two USB ports are supplied, but it's highly recommended that you get a powered USB hub, as the power supplied through the ports is quite low. You'll be fine if you're just plugging in a Wi-Fi adapter though. Video output is either through an analog RCA connection for old TVs or through the more typical HDMI for HD TVs and monitors. The easiest way to get started is to simply plug in a keyboard and mouse to the USB ports and boot your choice of graphical environment. For many projects though, it's recommended you run the Raspberry Pi in a headless mode, which means you connect to it over the network from another computer by using the terminal command SSH. You can also use PuTTY application on Windows to do this. The default username and password when doing this is Pi and Raspberry. Once logged in, you'll have remote command line access without the need for a monitor, keyboard and mouse connected to the Pi itself, though you'll have to do everything over the command line. There is no graphical environment there. Interestingly, there's also a set of GPIO pins, which stands for General Input and Output, equivalent to the digital I/O pins of an Arduino. However, you need to be a lot more cautious when working with them because A, it's a lot easier to overload the Pi and burn it out, and it's more expensive, and B, it operates on a non-standard 3.3 volts, unlike the Arduino I/O pins, which are 5 volts. Since most sensors that you come across will want 5 volts, you'll need to use a variety of transistors or MOSFETs or other electronics to modify a given circuit. That's not to say electronics projects are difficult on the Pi, but if you're planning to use circuits designed for an Arduino, it might be better just to plug your Arduino into the USB port and interface with the circuit like that instead. You can use them both together. I also suggest you buy a case as soon as possible. There's a good variety of cases out there and you can even 3D print one. The only thing you really need to know is whether or not you want an opening to access the GPIO ports. I picked up this clear case with GPIO access for about $10. Just like the Arduino, there's a number of accessory boards you can pick up and connect to the Pi, such as the GERT board or the Leica Explorer board, which adds a range of switches, LEDs, sensor connections and motor controllers. There's also mini LCD displays, and there's an official camera add-on, though you can actually use most USB webcams easily enough. There's not nearly as wide a range as there is of Arduino shields, for instance, but then if you need a particular shield, you can always hook up the Arduino and use it that way again. So what can you do with a Raspberry Pi? Well, as a few examples, last week I built a DIY Pogo plug, which is an anonymizing router that broadcasts a Wi-Fi network and then reroutes your communications through many layers of global Tor nodes. Effectively, it anonymizes everything you do on the internet. Next week I'll try adapting this into a public Wi-Fi network, but with one minor adjustment. It'll replace any and all images with a similarly sized picture of a kitten. Seriously. Right now I'm using my Pi as a controller for these cryptocurrency ASICs, which mine a few thousand Dogecoin each day. The cheap cost of the Pi combined with its extremely low power usage makes it ideal for this. Some people turn their Pi into a home theater PC for the living room, running either native Xbox Media Center or an optimized OpenELEC distro. There's even a dedicated ROM emulator called Pi MAME, which can run pretty much anything up to about the Dreamcast generation of consoles. There's so much you can do with a Raspberry Pi, and there's a huge community out there to support you. What are you waiting for?